Morning to all of you. All of you are welcome in chemistry lecture series of Dr. S.R. Huck. In today's video or in today's class, we shall discuss how to draw the Lewis dot structure of the covalent compound. In order to easily draw the Lewis dot structure of the covalent compound, we should follow or we should learn certain rules on the basis of which we can easily draw this structure. So let us start that what are those points which we should follow, or what are those steps which we should follow in drawing the Lewis dot structure. First of all, we calculate the number of total number of valence electrons in the compound. Suppose it is X. Then we calculate the total number of electrons required in attaining nearest inert gas configuration. Suppose it is Y. Then we find the number of electrons required in the sharing process. In sharing process, this will be equal to Y minus X. And then we shall find the number of electrons unshared. Suppose it is R, then this R is equal to X minus S. Now let us take some example for this. Suppose it is your carbon monoxide, for which we have to draw the Lewis dot structure. So for carbon monoxide, X will be equal to total number of valence electrons in the compound, that is, this will be equal to 1 into 4 valence electron for carbon atom, and number of carbon atom is 1, plus 1 into 6, 1 oxygen atom, 6 valence electron. So this will be equal to 4 plus 6 is equal to 10. Then we shall find the value of Y. Nearest inert gas configuration means S2P6 configuration, that is 8 electrons in the outermost orbit, except in case of hydrogen, whose nearest inert gas is hydrogen, it requires 2 electrons. So here is your carbon, so it will be 1 into 8 plus 1 into 8 for oxygen. This is equal to 8 plus 8 is equal to 16. Therefore, number of electrons required in the sharing process, this will be equal to S is equal to Y minus X. This is equal to 16 minus 10. This is equal to 6. It means 6 electrons are to be shared in between carbon and oxygen atom, means 3 pair of electrons. Now unshared electron R is equal to X minus S, and this will be equal to 10 minus 6. This is equal to 4. That is 2 pair of electrons. Now, after finding this, we write or we draw a skeleton of the compound. And in writing the skeleton of the compound, it should be noted that the least electropositive, most electropositive element or least electronegative element should be at the center, and the element having comparatively higher electronegative character should surround it. And in case if there is presence of hydrogen in a compound or there is presence of fluorine in a compound, then it should acquire any one end. It should not be at the middle at any cost. So it is your carbon monoxide. So here we write the skeleton. This is your carbon and oxygen. 6 electrons are to be shared, means 3 pairs. 4 electrons are unshared, means 2 pairs. 2 electrons here, 2 electrons here. Octet of this carbon is completed. Octet of this oxygen is completed. And each pair will form a single bond. So the dash formula for carbon monoxide is C triple bond O with 2 lone pair of electrons on each carbon as well as on oxygen atom. Now takes another example. Suppose it is your hydrogen cyanide. Then first we shall find the total number of electrons, valence electrons. Total number of valence electrons X. This is equal to 1 into 1. 1 valence electron for hydrogen atom. 1 hydrogen atom is there. Plus 1 into 4. 4 valence electron of carbon atom. Plus 1 into 5. 5 valence electron for nitrogen atom. This will be equal to 1 plus 4 plus 5. This is equal to 10. Total number of electrons required in attaining nearest inert gas configuration. That is why. Now here it is your hydrogen. The nearest inert gas of hydrogen is helium. So it will require 2 electrons. So it will be 1 into 2 plus carbon 1 into 8 plus nitrogen 1 into 8. This will become equal to 2 plus 8 plus 8. This is equal to 8 to 16 to 18. Number of shared electrons. Shared electron S. This is equal to y minus x. This is equal to 18 minus 10. And this will be equal to 8. Number of unshared electrons. This will be equal to x minus s. This is equal to 10 minus 8. This is equal to 2. Now after this, we shall draw the skeleton of the compound. Least electronegative carbon will be at the middle our most positive element will be at the middle. This is your HCN. Total number of electrons to be shared are 8, means 4 pair. So first we put 1 pair here, 2 pair, 2 pair, 3 pair, 4 pair. Now this hydrogen has completed its octet. It does not require any more electron. Number of electrons unshared is equal to 2, means 1 pair. This will be with nitrogen because this carbon has already completed its octet. So this will be the Lewis dot structure. If we join it by single bond. So the dash formula for this will be your HC triple bond N. Now let us take one more example. H2SO4. In H2SO4, total number of valence electron, this X, this is equal to hydrogen 1 into 2 plus 1 into 6. Sulfur has got 6 valence electron plus 4 into 6. Each oxygen atom has got 6 valence electron. So this will become equal to 2 plus 6 plus 24. This is equal to 32. Now total number of electrons required in attaining inert gas configuration. Again there is hydrogen atom, and this hydrogen atom will complete its octet. Therefore this will be your 1 into 2 into 2, 2 hydrogen atom plus 1 into 8 plus 4 into 8. 4 oxygen atoms are there. This will be equal to 4 plus 8 plus 32. This will be equal to 32, 8, 40 plus 4. This is equal to 44. Number of shared electrons. This will be equal to 44 minus 32. This is equal to 12. Number of unshared electrons. This will be equal to 32 minus 12. This is equal to 20. Now let us draw the skeleton. This will be equal to 32 here. This is your S, least electronegative element, O, H, O, H, O, O. 2 electrons shared here, 2 electrons shared here, 2 here, 2 here, 2 here, 2 and 2. Total number of electrons 2, 4, 6, 8, 10, 12. 12 electrons are shared. Now unshared. This sulfur has completed its octet. Therefore, it does not require any more electron. Hydrogen has completed its octet. It does not require any more electron. This hydrogen has also completed its octet. It does not require any more electron. For this oxygen atom, 4 electrons are there. So 2 lone pairs will be there. That is 4. This oxygen atom, 2, 4, 6 and 8 electrons. This oxygen atom, 2, 4, 2, 4, 6, 8 electrons. Now count the number of unshared electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So the dash formula for this compound, this will be equal to SO H O H O O, 2 lone pair, 2 lone pair, 3 lone pair, 3 lone pair. This is your H2SO4. Now take the case, another case, that is, suppose it is your C2H2. First you calculate X. X means number of valence electron. This X is equal to 2 into 4 plus 1 into 2 1 into 2. This is equal to 8 plus 2 is equal to 10. 1 valence electron for hydrogen atom, 2 hydrogen atoms are there. Number of electrons in attaining inert gas configuration. That is Y. 2 into 8 for 2 of carbon atom, and hydrogen will complete its group 8. Therefore, this will be equal to 2 into 2. This is equal to 16 plus 4 is equal to 20. Now, number of shared electrons. S. This is equal to Y minus X. This is equal to Y is 20 and this is your 10. So this will become equal to 10. 10 electrons are shared. Number of unshared electrons. This is equal to X minus S, 10 minus 10. This is equal to 0. So it does not have any unshared or lone pair of electrons. Now let us draw this skeleton. C2H2, carbon will be at the middle, H will be at the terminal position, 2 electrons are shared here, 2 electrons are shared here, 4. Total electrons to be shared are 10. Therefore, 6 more electrons means 3 pair. This hydrogen has completed, this of carbon has completed, this carbon has completed. So the structure becomes C triple bond C single bond H single bond H. Now till now we have taken such compounds which do not have any charge. Suppose there are some radicals which carry positive or negative charges. So how can we draw the Lewis-Strauss structure in those cases? Suppose it is your nitrate ion. If there is presence of negative charge, then in calculating the number of valence electron, we add 1 electron for each negative charge in the valence electron. As for example, suppose it is your NO3 minus. So number of valence electron X, this is equal to 1 into 5 for nitrogen atom plus 3 into 6 for oxygen atom plus 1 negative charge, so we shall add one more electron. So this will be equal to 5 plus 18 plus 1, this is equal to 24. This is the value of X. Number of electrons in attaining inert gas configuration. Inert gas configuration. X. Y is equal to 1 into 8 for one nitrogen atom plus 3 into 8 for 3 oxygen atom. This is equal to 8 plus 24 is equal to 32. Number of electrons in sharing. That is S. This is equal to Y minus X. Equal to 32 minus 24. This is equal to 8. Number of electrons unshared. This is equal to X minus S. This is equal to 24 minus 8. This is equal to 16. Now draw the skeleton. N O O O. Total number of electrons to be shared are 8. So 2, 4, 6, and 8. Nitrogen atom has completed its octet. So unshared or electrons not participating in bonding process are 16. This is to be distributed. This oxygen has got 2 electrons. So 6 electrons are needed here. 6 electrons are needed here. And this is your 4 electrons. So this is your 8 electron, 8 electron, 8 electron. This carries one negative charge. So this dash formula will be like this: O double bond and O with one negative charge, 2 lone pair here, 3 lone pair here, and 3 lone pairs here. Take one more example. Suppose it is your carbonate ion. Carbonate ion. Number of valence electron X. This is equal to 1 into 4 plus 3 into 6 plus 2 electrons to be added because carbonate carries 2 negative charge. So this is equal to 4 plus 18 plus 2. This is equal to 24. Number of electrons in attaining inert gas configuration. So 1 carbon atom 1 into 8 plus 3 oxygen atom 3 into 6. This is equal to 8 plus 18. This is equal to 26. Now number of electrons required in the sharing process. This is equal to 26 minus 24. This is equal to how much? This is equal to number of electrons required in sharing process. Sorry. Here it will be 1 into 8 plus 3 into 8. 8 electrons will be required. This will be equal to 8 plus 24 is equal to 32. So S will be equal to Y minus X. This is equal to 32 minus 24. This is equal to 8. Number of electrons unshared, X minus S. This is equal to 24 minus 8 is equal to 16. Now draw the skeleton. So carbon will be in the middle because it is least electronegative. Total number of electrons to be shared are 8. So 2, 4, 6, 8. Carbon atom has already completed its octet. So unshared electron should be distributed on oxygen atom. So this has already 2 electrons. 6 electrons are here. 8, 10, 12, 14, 16 electrons. In this way, this is your 8 electron, 8 electron, 8 electron, and this carbon has already 8 electrons. So the direct formula will be like this: C double bond O, O, O with 2 negative charge, and lone pair of electrons, 2 lone pair here, 3 lone pair, 3 lone pair. So this was the case of a negatively charged ion. Suppose we take the example of a positively charged radical. Then in case of negatively charged radical, we add 1 electron for each negative charge. In case of positively charged radical, we subtract 1 electron for each positive charge from the valence electron. So suppose it is your NH4 plus. NH4 plus. The number of valence electron X is equal to 1 into 5 plus 4 into 1 minus 1. Minus 1 because there is 1 positive charge. So this is your 5 plus 4 plus minus 1 is equal to 8. Number of electron in attaining inert gas configuration. This Y is equal to 1 into 8 plus 4 into 2 because hydrogen will complete its octet. So this is your 8 plus 8. This is equal to 16. So number of electrons required in sharing process Y minus X, 16 minus 8. This is equal to 8. Number of unshared X minus S. This is equal to 8 minus 8. This is equal to 0. So there is no lone pair of electron. Now let us draw the Lewis-Dot structure. First we shall draw the skeleton. Hydrogen will be at the corner, as I have told you that in case of a compound containing hydrogen or fluorine, these should be placed at the corner. 2 electrons, 2 electrons, 2 electrons, 2 electrons. That is total number of electrons shared are 8. This nitrogen has completed its octet. Hydrogen has completed its octet. This hydrogen has also completed its octet. 1 positive charge. So this will be your H, N, H, H, H. 1 positive charge. Take one more example. Suppose I am taking H3O plus hydronium ion. Number of valence electron X. This is equal to 3 into 1 plus 1 into 6. This is equal to 3 plus minus 1 for one positive charge. 3 plus 6 minus 1 is equal to 8. Number of electrons in attaining inert gas configuration Y. This will be equal to 3 into 2 plus 1 into 8. This is equal to 6 plus 8 is equal to 14. Number of electrons required in sharing Y minus X. This is equal to 14 minus 8. This is equal to 6. Means 3 pair. So number of unshared pair. This is equal to X minus S. Means 8 minus 6. 2 electrons. Means one lone pair will be there. Now this is hydrogen containing compound. So hydrogen will be at the corner in the skeleton. So the structure will be your H, O, H, H. 6 electrons to be shared. 2, 4, 6. Hydrogen has already completed its octet. Therefore, it does not require any more electron, any one of the hydrogen. And 2 electrons are left. So these 2 electrons will be the oxygen atom. That is, this oxygen will carry one lone pair of electron. So this is completed octet. This will be one positive charge. Dash formula for this will be H, O, H, H. And this is your one lone pair. And this is your one positive charge. So this was about the Lewis-Dot structure, how to write. And on the next turn, I will tell you about the formal charge. Thank you.